Hi, you guys. I'm going to work through the examples of unrelated rates that we did today in class. I'm going to create a separate video for each example. So for this first example that we did, we're given that a right cylindrical tank is filled with water. The tank stands upright and has a radius of 20 centimeters. I left out a few words there. How fast does the height of the water in the tank drop when the water is being drained at 25 cubic centimeters per second? So we are given dV over dt, the rate of change of the volume. And it's important to pay attention to the wording. So it's saying, how fast does the height of the water in the tank drop when the water is being drained? Meaning that the volume of water is going to be decreasing as time is passing. So we would say that dV over dt is equal to negative 25 cubic centimeters per second. And we are being asked to find the rate of change of the height of the water in the tank. And we'll expect that to be negative since it's implied. The question is asking how fast does the height of the water in the tank drop. And that is, and we are given that the radius of the tank is 20 centimeters. Now, as time is passing and the water is draining out of this tank, the radius is going to stay 20 centimeters, right? Until it gets to the very bottom and it stops covering, the water stops covering the very bottom of the tank. So while the water's draining out, for what we're calculating dH over dt for, we can assume that dr over dt is equal to 0 centimeters per second. So since the radius is staying constant as the water is draining out, we can actually rewrite our volume formula with 20 substituted in for r before we even differentiate. So that's V equals to 400 pi times h. Okay, so now we've stated what we're given, we've stated what we need to find, and we can actually differentiate. And I'm going to pull the constant out. Okay, so this is a pretty easy one. Left-hand side just becomes dV over dt, 400 pi times dH over dt. Okay, so we can see that we have dV over dt, which we can substitute in, and then it's just doing a little algebra and solving for dH over dt. Okay, so when we divide by 400 pi on each side of the equation, we will get that dH over dt is equal to negative 1 over 16 pi. And the units on that, remember, you look at, okay, I just solved for dH over dt. Think, what are the units for h, the height, in their centimeters, I believe? Yes, centimeters. And then time is in seconds, so this is going to be centimeters per second. And now we can write our sentence to summarize our answer. So the height of the water in the tank is dropping at a rate of 1 over 16 pi centimeters per second. Done. Because we're just given that we're not given a specific time, so that means that the volume is just draining out at a constant rate of 25 cubic centimeters per second, and therefore the height will be dropping at a constant rate of 1 over 16 pi centimeters per second.